This video is on solid revolution, volume of solid revolution, and the shell method. And here I have this yellow region right here. It's bounded above by the graph of sine of x plus 1. It's bounded below by the graph of cosine of x. And this is the line x equal to 3 pi over 2. So I'm going to take this yellow region right here and revolve it about the line x equal to 3 pi over 2. And this is what the solid revolution looks like. So I want the volume of the solid revolution. And here's the yellow region in the solid revolution again. And here's the axis of revolution. And I'm going to use the shell method. So we're going to fill the solid revolution with cylindrical shells. And notice that the solid revolution does not include this part and this part. And so I'm going to go ahead and fill this up with 10 shells. Here's shell number 1, number 2. So this is what the 10 cylindrical shells will look like. And so for shell number 1, so here I'm calculating the volumes of the 10 shells. And so altogether, the volumes of the 10 shells is about 99.7. And therefore, the volume of the solid revolution that we want will have a volume that is approximately 99.7. And so if we want the exact answer, then we need to divide the solid revolution here into an infinite number of shells. And here's what the one shell will looks like. The distance from the center here to here, that's the outer radius, and then the distance from here to here be the inner radius. And then right in the middle right here, the distance from the center to right here is called the average radius. So let's call the distance from the y-axis to right in the middle right here. Let's call it x sub I star. So x sub I star is the distance from the y-axis to the middle right here. And the distance from the y-axis to here is 3 pi over 2. Therefore, the radius for this ith shell will be 3 pi over 2 minus x sub I star. And so that's going to be the average radius for this ith shell. Now, to calculate the height of the shell, then we'll need the equations for f of x and g of x. So once again, this is x sub I star, and so the distance from the x-axis to the graph of g of x. So the distance from here to here will be g of x sub I star. And then the distance from here, from the x-axis up to the graph of f of x will be f of x sub I star. And therefore the height of this shell will be f of x sub I star minus g of x sub I star. So once again, the average radius for this ith shell is 3 pi over 2 minus x sub I star, and then the height will be f of x sub I star minus g of x sub I star. And now we can find the volume for this ith shell. The volume of the ith shell or cylindrical shell is 2 pi times the average radius times the height times the thickness. And so we have just found that the average radius is 3 pi over 2 minus x by star. And then the height is f of x by star minus g of x by star. But f of x is sine of x plus 1, and g of x is cosine of x. And so f of x by star minus g of x by star will be sine of x by star plus 1 minus cosine of x by star. And then the shells here, so let's make them all the same thickness, and so let's call it delta x, since they all have the same thickness. Instead of delta x by, we can just use delta x. And so the volume for this ith shell would be 2 pi times the average radius times the height times the thickness. And now let's calculate the volume of n number of shells. Once again, this is the volume of the ith shell, and here's volumes of n shells. So this would be volume of shell number 1, volume of shell number 2, and then volume of the nth shell. And then using summation notation, then we have I running from 1 to n. And then if we divide the solid of revolution into an infinite number of shells, then this is what it would look like. Here we're allowing n to run to infinity. And just like before, if this limit here exists, then we rewrite it, we defined it as this definite integral. The integral from 0 to 3 pi over 2, and then 3 pi over 2 minus x, and then sine of x plus 1 minus cosine of x, and then here we have dx. The 0 to pi over 3 pi over 2 is because we're going from 0 to 3 pi over 2, which is the axis of revolution. The axis of revolution is the line x equal to 3 pi over 2. And now let's find the value of this definite integral here. So here's a definite integral right here, and then we can rewrite it as 3 pi over 2 times this expression right here, and then minus x times this expression right here. And then this is what it would look like. Now this part here is easy to integrate, but the part over here is going to involve x times sine of x, and then also x times cosine of x. And then for the integral of x times cosine of x times sine of x, then we have to use what's called integration by parts, and it's going to be sine of x minus x cosine of x. And then the part that's for x cosine of x, then again we have to use what's called integration by parts, which is, and then it's going to be x sine x plus cosine of x. And if we do it, if we do integration by parts here, this is going to take at least 10-15 minutes. And so for this indefinite integral right here, we could also use a numerical integration like trapezoid's rule, and then it will give us 99.3729. And so the volume of this solid, the solid of revolution that we want, will be approximately 99.3729. And then a few moments ago, when I divided the solid of revolution into 10 shells, the volumes of the 10 shells was 99.7052. And here's the volume for an infinite number of shells. We can see that they're very, very close. And that's the end of the video.